So we'll be discussing primarily on the Google Cloud Platform space. We'll be covering how it is structured, how the backend data centers are structured, how the compute services are being offered by GCP, what are the storage options, and how the network is maintained. You know how it is spread out in terms of regions and data centers. So before even we go to that, I would start with the concept of infrastructure provisioning, and we'll basically be touching upon you know some of the historical aspects, like how it was used to be and how it is done presently in the companies. So I would like to go with one of the instance. Uh, you know, Back in like 10-15 years back, when companies used to provision servers in their data centers, there used to be a full-fledged process of documentation approvals, and there used to be a weekly the process used to spread out in weeks, basically, to get servers. And then whenever there used to be an application project on which so application projects used to come later, but first there used to be a full fledged process being followed in terms of infrastructure, servers, networking, you know. But the situation has changed, immensely, and we are living in an area. We are living in times when the infrastructure provisioning is happening in matter of minutes, in matter of seconds, through a set of API calls that happens behind the scene. Uh, all we have to do is we have to go to a UI. It's a nice looking UI. As you can see, this is for Google Cloud. And if you see over here, we have different options like Compute Engine, Kubernetes, VPC Network. These are different services being offered by Google Cloud. All we have to do is, like, we have to click on one of the option. We have to provide some configuration points, and we need to click the button, okay, provision this particular compute service. That'll happen in matter of minutes. But having said that, there are obvious advantages and obvious disadvantages. So we'll be covering that today. But first of all, we'll be covering some of the terms like infrastructure as a service. So as I was talking about on-demand availability of computing power, on over the internet, over, as a service. This is what we call as infrastructure as a service. So it all started, the major players being Amazon in this space. Amazon is leading the market with, other players like Microsoft and Google following them up. And Amazon used to be a book selling company, as we all know previously, and they used to have their online portal. I'm talking about the time back in 2000, before 2007. So there used to be, the how it all started was like Amazon started harboring infrastructure in terms of servers, compute components in their own data centers to support the traffic spike on their online application portal. Now, what happened was, like, Amazon used to um, sell books, and later on they developed, a full-fledged portal that we have today. You know, um, but it started with a book selling business, and they used to support the backend infrastructure. They used to have their own data centers, and they started created more, creating more data centers in order to support their traffic, the user spikes. What eventually happened was, the spikes that they were seeing in their application never used to last consistently. Um, And as a result, the compute uh, capacity and power they used to have in data center used to lie unused basically. So they were getting additional expenditure on that compute power, which was not getting utilized. It was getting utilized only in the in time of user spike. But as a business model, uh, there used to be a guy called Andy Jassy, which Andy Jassy was the core team member. Um, that team worked on the proposal of renting out the compute power, the server, to other customers on on a specific cost basically. And the unused capacity they started renting it out to other customers in exchange of some cost that they used to pay. And Andy Jassy is, I think, currently the CEO of AWS, and he was the person who was in original team when it all started. So this came up as a business model for Amazon, and I think they launched EC2 back in 2007, somewhere around that time, and it was a virtual VM hosting service. They used to rent out VMs on demand. So it all started from there with Google entering this area around 2011. Yeah. So coming back to infrastructure as a service. So this is what we call, when we are providing infrastructure to a customer as a service over the internet, over the network, right? By giving them nice looking UI, options to configure the different options. What like examples are like compute engine service. uh, I'm talking from Google perspective. We have compute engine, which is nothing but a VM service offered by Google. Then we have cloud storage. So I'll just go by here. So let's say if I'm clicking on compute engine, this is the Google Cloud Platform UI, which I'll explain later, like how to set up a trial account to start exploring this. This is my trial account, as you can see over here. I have already signed up with my Gmail account. You can also do that, but we will discuss completely later. So as you can see, this gives us an option to create a VM instance basically by just clicking on this button. So I am provisioning the infrastructure on the fly as a service. So this is infrastructure as a service concept, and it gives you, okay, this would be the cost, that will be incurred on a monthly basis. And it's kind of a breakup, as you can see over here. Now coming back to the other concept. So infrastructure as a service is providing you the raw compute capacity, and you can configure other applications on that, on top of that. But other area is platform as a service. So platform as a service is nothing but it provides all the software features and tools needed for application development as well on top of IS infrastructure. So just an example is like in speaking from Google Cloud platform perspective, we have services like Cloud Run and App Engine. So they are nothing but it's more of an application stack on top of infrastructure. It's kind of like adding operating systems, middlewares like databases and other runtimes as a full as a packaged environment on which you can directly start doing your application development. So this is nothing but a platform uh, that has been provided for a developer, for example, to start working on their applications, because all the application dependencies, softwares, operating systems are pre-installed on that platform. So this is one model. We call it as platform as a service. Then on the last one is software as a service, which is nothing but we use it in most of our day-to-day activities. Like very good example is the Gmail that we use. It is not, and YouTube, a very common example, streaming service. So all we see is a web application, and it comes with some premium subscription and some free subscription, right? We are not seeing behind the scenes topology. We are not seeing what infrastructure is, on what are the software that are running behind the scene. All we see is a application. We are interacting with a subscription model. Okay, so these are the three service model, that has come up with the advent of uh, cloud. So I would move on to cloud computing as a definition. So just I'll go by the points. As you can see, it's on-demand self-service. Yes, yeah, it truly fits the definition. If you see over here, I'm seeing a Google Cloud Platform. It's on-demand service. Whenever I need some instance, I can simply go to the UI and I can create my account. I can set some free trial, and I can go and I can create instance, which is nothing but a virtual machine, and I can even create some. For example, I want some storage solution to be built. I can create a bucket. I'll come to the terminology later, but I'm just trying to explain cloud as on-demand self-service. And yes, it can be accessed from anywhere. Yes, it's getting in accessed over the internet, so it hardly matters where you're sitting. You can access it from anywhere. Elasticity, of course, you can provision the number of resources that you need. Elasticity is like, okay, you know, I can create as many buckets as I need for my project or for my application. I can create as many instances I need for my. So elasticity aspect is there. Then agility, of course, that is what is the main distinguishing factor. Agility has come. Agility is nothing but the ability to quickly spin up resources as you need them, you know, which I have just shown. I can just do it on the click of a button. So the agility has come into the process. This agility is it's to the very core of this whole uh, cloud, which was not used to be the case back 20 years. If we go back, it used to be a full-fledged process. So agility has come, and it has helped immensely uh, to the organizations who are low on, the organization that do not want to spend much on the cost. They want to experiment. I'm talking about the startups, startups or other small organizations. They can, quickly spin up the services. They can utilize them, and they can shut down as and when it is needed. So agility is there. Then measured service, yes, you need to pay certain expenses, and it's a model. They call it as pay as you go. Only pay for the services you are consuming. It's quite different from what it used to be. There is no upfront commitment you need to make. You do not need to commit for, okay, certain period of time I will be paying this much amount of money. Because the problem with that model is, like, let's say you have bought some server capacity for a period of 3 years, and you have paid certain amount of dollars as per the contract. Now what happened is, like, your application on for which you have purchased the capacity does not require that much, for instance, does not require that much compute power. And as a result, you're not able to utilize the full, you are basically wasting that money away, because that you're already paid that amount. But this is not the case here. You can scale down, you can scale up the services, and you can pay according to the actual usage of the service. Resource pooling, yes, this again comes into a picture where computing resources are pooled to serve multiple clients at a time. So this was the definition of cloud computing in general, and I'll come to the core infrastructure of GCP. Now it is so we'll be shifting our discussion to Google Cloud Platform specific now. So we'll start with as you can see over here, GCP is a suite of cloud services hosted on Google infrastructure that is planet scale. Now this is a very important term when we call them as planet scale. Planet scale is nothing but the data centers, the backend data centers I'm talking about, they are spread out over different geographies, like different continents, and uh, in a particular continent or we call it as a region, you know, uh, in terms of GCP. So if you see Google, the third point I would refer to Google Cloud Infrastructure Services are available in locations across North America, South America. So these all are different continents, and how they break it down is they have terms called regions and zones. So regions are nothing but independent geographic areas that consist of zones. Zones, basically a region is divided into zones. Zones is nothing but a physical data center, or it could be one or more data centers collected together as a zone. All zones connected with highly redundant network, with low latency network. So I would definitely be more interested in showing this picture over here. Now this is this clearly depicts like how vast is Google Cloud infrastructure. It's distributed among different continents, regions, different data centers. These all are uh, data centers of Google. They all are connected with very um, low latency, redundant network. So as you can see, now this may not be the latest diagram, because Google keeps on adding more data centers. They keep moving their infrastructure to more data centers. They keep on acquiring more backend data centers. So this shows like some of the zones here, like London, Belgium, Paris, and India, like Delhi, Mumbai. So these all are the locations where the Google data centers are located. Whenever you provision a certain service, you need to specify the region, you need to specify the zone in which you would be provisioning that particular service. Like as an example, if I go back to my original example of, I was trying to provision a VM instance, a virtual machine. So when I click on create instance, it will ask me a region, which is nothing but, okay, in what geography you want to place your, VM. So let's say I select US Central, and under US Central, there will be different zones, different data centers. So I can choose one of the data center US Central 1C. So this is where my VM would be created, in this data center basically. So basically the host, I hope you all are aware of the concept of VM host. So basically virtual machine is nothing but it is it's provisioned on certain physical computer. We call it as a host. So that host would be located in certain it would be basically a server sitting in certain rack in certain data center. So this is what we are trying to do here. So what I am trying to uh, achieve here is like I am saying like, okay, create my VM in a in a host that is located in a data center present in the US Central 1C zone in the region US Central 1. So this is how it works. Now coming back to my original diagram here. So it shows the geographical distribution of Google network. Just before that is like, so coming back here is like these Data centers, they are connected with uh, highly redundant low latency networks, and which is which kind of looks like this, these all data centers are connected like this. So there are green and blue lines, as you can see. There are submarine cable networks, so all these are the cable networks, as you can see, that connects the different data centers. And having said that, so it's a planet scale architecture, and this is some of the figures, some of the numbers, as you can see. There are 34 regions, 103 zones, some network edge locations, countries and territories being covered. As you can see, Google keeps on expanding. There are other new regions, as Google has mentioned. This may not be the latest one, but for latest, you can always check the Google website. So I think I have the link over here. I'll just try to, yeah. So you can always check over here, Google data centers, locations. This is the latest picture over here, as you can see. Okay, I'll just come back to my original point of discussions. Okay, we discussed about core infrastructure, and now we'll just move on to the GCP resource hierarchy. So now, having said that, Google Cloud Platform is nothing but a collection of service. Like, for example, certain services are in compute area, certain are in storage. We have just seen the compute service. So, what we are trying to do here exactly is we are trying to provision certain services, whether it's a VM or whether it's a storage bucket on which we need to keep certain files, or whether it's a database, or whether it's a network, VPC, virtual private cloud. It's nothing but a network service that gives you, the ability to provision your own network, your own firewalls, your own security groups, your own access control list, your own IPs, CIDR ranges, everything. I'm talking in pure networking terminology, but it is being offered as a service by Google Cloud. So different resources, different services are there. But what is the organizational model? How these services are being organized in in GCP? So the resource hierarchy that I want to talk about here is, there is a certain hierarchy, as you can see. There is something called as my first project, which is nothing but there are certain, it's a logical container of your resources. This is the resource hierarchy I'm talking about. On top, there would be an organization, and then there would be certain project, and within a project, you would be having your own resources, which is nothing but like compute engine, cloud storage, VPC, etc. So let's talk about, let's cover these points. It provides inheritance for access control and organizational policy. It provides hierarchy of ownership. So, you know, let me cover this thing first. Like, if you want to set up your own GCP account, all you have to do is you have to sign up on Google. Basically, you have to create a Google account. Okay. And so Google cloud offers a 90-day free trial for everyone, who wants to play around with these services. So all you have to do is you have to create your own Gmail account and you need to sign up with your credit card basically. So you need to provide your payment information, enable the billing here, as you can see. Okay, so this will all be asked as part of the sign up process. So in very simple terms is what we have to do is you have to get a Gmail account, and on you need to go on the sign up page of GCP, and you need to enter your credit card details. No amount would be deducted. It is just for the payment information as a mandate given by GCP to enable the billing, and then you will get a certain credit. They call it as, yeah, 90-day trial, $300 free credits to run, test, and deploy workloads. So that is the very first thing you'll have to do whenever you want to start learning, GCP. So after you have configured your GCP account, you'll be presented by this portal. Basically, you'll be presented with this dashboard on which we are on right now, as you can see on my screen. So it tells you about, okay, what is your project? There'll be a default project that'll be created for the very first time, and different set of services, as you can see over here. And you'll always have the ability to create new projects. So why I'm telling this all is because projects would act as logical containers of your resources. Whenever, let's take an example of a real-time engagement, a real-time, uh, engagement in a company. So whenever some project comes, how we will be provisioning resources, we'll be provisioning under the logical containers over here, like this. We'll create certain projects. Could be a development, could be a testing project, could be a production. So this all will be separate the resources, and we'll do migrations, etc. among these projects. Okay, and now having said that, why GCP is having this kind of resource hierarchy? Because it promotes the control in terms of the access, in terms of the policies that you need to implement. Certain policies or certain access controls you can implement at the project level, which would be applied to every service that is in that project. So just an example. So inheritance and hierarchy of ownership, this is how the resources and services are organized. Then we have seen the project and services. We have not seen folder and organization. So organization is nothing, but it would be a top level container over here. In my case, it is coming as no organization because I have not signed up with it is basically tied to the domain of your organization. So for example, if my company is google.com, so over here it will appear as google.com, and under that, so it's a logical separation basically. So it is always tied to the domain, and under it we can always create folders. Folders are not present right now, but if you see, uh, we can definitely create that over here. But having said that, I just want to make it clear, like this is how the resources are. Because in a real-time scenario, if there is a company in which the developers are working on GCP, typically their accounts would be tied to the domain of the company. For example, if a developer is working in a GCP project, that developer will have the access given through the actual domain ID. So there will be, so all those things comes into play. But for now, we do not need to go into that much detail. I think we just need to stick to our first project that you will create whenever you sign up on the account, for GCP. So you'll get 90-day time. You can explore services and you can create VMs. You can utilize different services. They are offered as a free, under free trials. So, so this is some terminology we already discussed. Organization resource, the root node of the Google Cloud resource hierarchy, as we have seen. Folders are additional grouping mechanism on top of projects. You can group projects by department. For example, for sales department, if there are 10 projects, we can group them under. So nothing but we are trying to organize. So this is how the hierarchy looks like. There will be a company, department, projects, and actual resources. I'm not discussing about IAM. We'll get to that, identity and access management, because this is very critical part. I mean, every major platform will have the access controls in place, and GCP is no different. They have a very comprehensive framework. They call it as identity and access management, to control access, to control permissions, to control policies given to the people, to control how much they can access a particular service. We'll get to that. Billing we have already discussed. I'll just again discuss it again. So whenever you sign up for a GCP account, you need to give your payment information in terms of a credit card. It will be reflected as a billing account. So I'll show in my case, there's this option, billing, and yep. So this is my billing information. Although I cannot show you the payment settings. Payment settings will have the your credit card information, everything that you will give, payment overview. So over here you see my free trial credit, this much is left and this much days are remaining, in my free trial. So all that information you can access. So basically every account will be linked to a billing account, which will reflect your usage, your cost basically. Okay. And then there are different options. As you can see, you can generate reports, you can do some cost management, right? You can see the cost breakdown, you can set some budget and alerts, you can control the cost. Okay, like for example, I want to like over here I've set one trigger here. I can always create my budget. Okay, if my budget crosses certain limit, I should be alerted. So all those mechanisms are there. So this was billing and payment profile. Yes, individual, like we can set up by giving our credit card information. So this is payment profile, and there are two type of cloud billing accounts: self-service that I just showed you all, that is one, and another is offline account. It is uh, a different way of doing the payments. Invoices are sent by email and electronic. So but it's a different case altogether. But you will most commonly be seeing the first option, self-serve online account, which I just showed you. Okay, this slides talk about how to sign up for a free trial, which I have already discussed. Okay, GCP offers 3-month free trial with $300 free credit, and these are the links uh, to the Google Cloud Console and command line. Okay, now let's talk about interaction with GCP service. So one way that I was just showing till now was the graphical user interface of interacting with different services. For example, if on my left I have these options: compute engine, Kubernetes engine, cloud storage, BigQuery, VPC network, Cloud Run, SQL, etc. So everything I do here is I do from a UI. Like for example, I want to create a bucket. I'll click on my simple create bucket option. Again, I'll give some, the name should be distinct. I'll give one example, bucket here. So for example, if I select a very common name, there is every possibility that this bucket name is already taken. So it should be globally unique. When we say globally unique, nobody else in the world should have a bucket with this name. So I'll just give some very random number and let's see whether it has not been taken. So we can take this thing, okay? And we have these options whether you want to set up a multi-region or a regional, low latency within a single region bucket. So this is nothing but a topology of the bucket. So storage class, again, we'll be discussing more in the detailed discussions, and how you want to control access to objects again. So over here, we'll just create confirm build. So I am trying to create my bucket, okay, through the UI. So this is one way of interacting with the GCP services. Now the other way is command line interface. Now the question arises why we need command line interface. So if you see over here, there is this button on the top right corner. This says activate Cloud Shell. So this is the native GCP Cloud Shell, which is nothing but a command line interface provided by GCP. So let's wait while it provisions the Cloud Shell machine. It is nothing but a Linux based system provided. It comes with your GCP account. Okay. So as you can see over here, it's a typical Linux machine with certain, so it gives us ability to interact with different services through command line. Now, as an example, if there is a actual project going on and there is a need to provision 15 buckets for storage of different kind of files, we would not be doing it through a UI. Typically, it would be certain script that will be running on command line, or that would be done through sophisticated deployment tools. But having said that, there will be a need of automation, through scripts. So that is where the CLI comes into picture. You cannot do these, UI activities in actual project scenario. You'll have to rely on scripting. You'll have to run some script to provision, let's say, certain amount of uh, buckets, instances with certain configurations, right? That is where the CLI comes into picture, and this is the significance of Google command line interface. You can always provision it on your local system as well, and under the command line prompt or a PowerShell. There are separate ways for doing that, and GCP provides that full-fledged walkthrough and documentation. But we'll be discussing about this over here. So let's talk about one command. We'll just run one sample command, okay? Cloud Shell GCP list buckets. I'll just random listing buckets. So we'll try to list the bucket we just created, okay, through command line. So we have this option over here, gcloud. So I'll just paste it. Storage ls. So as you can see, it is just listing down the bucket I just created in this particular account. So this is another way of interacting with services. And then the third way is through the client libraries. Now, what is a client library? I'll take one example. So I'll take Python client library for Google Cloud. In actual project scenarios, there will be a typical programming language, could be a Java, could be Python, in which you'll be writing certain code, and that code needs to interact with these services. For example, we are writing certain code, we are writing a data pipeline. We're trying to read data from cloud storage bucket. Well, so definitely we'll be needing the client libraries, the libraries for Python. So these are different libraries for different services for Python language. So for example, we'll look for Google Cloud Storage Library. So over here, this is the Google Cloud Storage. So this is Python client for Google Cloud Storage. So we'll be using this particular library to create buckets programmatically through Python code. This is one example I'm giving. Or to read data programmatically from a bucket, you know, through Python language. So that is another way of accessing and interacting with GCP service. So this is nothing but the same. This diagram is again the same thing. Cloud console, we call it the UI. Cloud SDK and Cloud Shell is, we have seen that. And APIs are nothing but, this is what I was trying to show here, Python client for Google Cloud Storage. And there is a fourth option also, Cloud Mobile App. This is a very recent option that the Google has rolled out. You can access over the Cloud Mobile App as well. So some of the diagrams I'll be covering now, that's specific because it's important to know, what are the different services that are available. So some of diagrams I have taken from the Google website, and it's a very very comprehensive and intuitive diagram over here you can see that talks about the different compute services offered by GCP, and it range from like compute engine to Kubernetes to Cloud Run to Cloud Functions. Now I'm sure like compute engine we have already seen. It's nothing but it's a system of virtual machines basically. And Kubernetes engine, let's briefly discuss about that. So this basically relates with the containerization of your workloads. If you are running, if you guys are familiar with Docker and containers and container orchestration, then it'll be very intuitive. This is nothing but a managed Kubernetes, managed container service offered by Google Cloud. So this is another computing option. As you can see, it's for containerized applications. Then we have Cloud Run, which is again serverless. It's important to understand what is serverless. Let's go to Cloud Run, again a compute service for containerized. So serverless options are nothing, but it's an option where you do not need to configure any server. It's a So all the behind the scene activities would be taken care of by Google, would be managed. We just need to create our service. So this again, one of the compute serverless service. Then we have Cloud Function, which is nothing but event-driven compute. Event-driven compute is like if you want to run certain amount of code only in condition of certain event. Like for example, if I want to upload certain file to a cloud storage bucket, and once that file is uploaded at a certain location in a certain folder under a certain bucket, I need to trigger my function would be nothing but a piece of code written in certain programming language, okay, that can be configured. So this is again, you're performing some cloud based on certain event that is happening. So the diagram, the bottom line says like committed resources, and on the right side it says usage based. So, so committed resources are like, okay, you have spin up an instance, you would be provisioning it for certain amount of time, you know, for to support your application. But cloud function on the right hand side would be on a usage based, like how much of the events are basically triggering that particular functions. And cloud run again would be like there is no server being provisioned, it's a serverless container that you are running. So pricing and all it talks about. And then this slide talks about storage and databases. Cloud storage we have already covered. It's a binary object data. Like it's nothing but it resembles a typical drive, the Google Drive, for example, where we keep our files. Could be any file, it could be an image, a media, anything. It could be any file. We can keep that in cloud storage. We already, so it's nothing but an object storage. Then a relational paradigm. Yes, traditional databases. There are managed databases like Cloud SQL and Cloud Spanner. So let's quickly take a look on Cloud SQL. So I would explain this with one example, like going back 15 years or 20 years, there used to be, I'm sure like people who have worked on databases like Oracle 11G 12C, uh, we used to host those databases on physical servers, under different topologies, under in our data centers. So typically organization used to have a team of DBAs managing the databases, taking backups, um, doing all the management activities. But uh, cloud, specifically GCP says, okay, you create your instance, okay, we will do the management. You create your database, you choose your flavor. So let's do one thing. So speaking of flavor, it gives you an option what database engine you want to choose. You can set up a MySQL database engine. You can set up PostgreSQL database engine. You can set up SQL Server. But the only thing would be, like for example, SQL Server I have chosen. I I would just be supplying this information. Okay, what would be my instance ID, password? What would be my database version? Okay, and some configuration, whether it's for development or production. I'll see, all the configuration on my right hand side, as you can see. Okay, and I'll give some more information, and I'll simply say, okay, create instance. While all the management of this database would be taken care by GCP. It's a managed SQL Server instance I am creating. So it's a managed solution provided by GCP. So what is the advantage of this is I can, set the right configuration. For example, taking an example, I can set the right memory, I can set the right storage, I can, set the computing, like how many CPUs I want to, to support my workload. That is the only thing what is the network throughput I want? What is the disk throughput I want? What are the IOPS I want? That is the only thing I am concerned about. I just have to set that configuration. Once I am done, I can directly start developing my application. I won't be bothered about uh, how to manage my database because that is being done by cloud, the GCP. So this is what we call relational cloud SQL. Then there is another flavor of we call it as cloud spanner. It is for high availability mission critical applications like financial fintech apps, where the consistency is of utmost, like for example, stock market databases. Cloud spanner is the option for that. Definitely we'll be discussing in detail in the actual sessions. And the non-relational options are also there, as you can see, Cloud Bigtable. I mean, earlier there used to be relational databases that used to conform to certain formats, right? You can only insert data that conforms to certain format. But in modern times, we have seen databases like MongoDB, you know, acting as the backend for major, web applications, because it provides you the advantage of, that flexibility of the schema, you know, and as a result, there is no hardwired schema that you need to confirm. So a lot of application these days are using non-relational databases, and GCP do provide support for them. So these are some of the managed services. We call it Cloud Bigtable, Cloud Firestone. So mobile and web apps backends they can act as. So let me also show what is Cloud Bigtable. So these are some of the managed NoSQL non-relational databases that you can create, and they can act as a backend to contain, could be a product information, session information to your web applications. Okay, we can. So again, these all are managed instances. All we have to do is like I have to just click on this thing. I need not worry about the other, like it will give me a pricing estimate, okay, based on my storage type and my cluster type. So this is, and then the warehouse, it's a flagship product of GCP. They call it as BigQuery. It's again a serverless solution for your business intelligence and data warehouse projects, where you want to build dashboards, you want to build reports. Okay, so we have BigQuery for that, and this is over here. If you can click, we'll see over here. So this is the BigQuery UI. It gives you, and it is serverless. All you have to do is you just have to create, you can start creating your data sets. Data set is nothing but it's a way of organize, it's kind of a, logical organization. Within data set, you will have a certain tables, tables, and you can start querying them directly. You can, with a normal ANSI standard SQL queries, you can write and query data. So as you can see, it is good for enterprise data warehouse, analytics and dashboards. So these were the overview of storage and database service. And moving on, this talks about the networking. Of course, all the applications, all the services that you create in Google Cloud Platform, they are tied to one another with the help of a network. Google Cloud Platform offer that service as, we call it as virtual private cloud. It is the core service provided by GCP along with compute and storage services. So as you can see, we can set up our own custom networks. We can define our own subnets. We can define our own. I'm sure the guys who are working in networking domain would be able to absorb this very quickly. So having subnets, having different firewall rules, different routes, as you can see, different options are given here. Like you can set up your own firewall, you can set up your own route, you can do network peering, which is nothing but two VPCs, two different networks are talking to each other through a pairing connection. You can share your VPC, okay, and then you can use your own elastic IP addresses. So as an example, if you are launching your VM or your compute resource, you will be launching that in certain network that will have certain subnetwork that will have certain firewall rules that will have certain IP addresses, right? So all these are the core ingredients of GCP. So VPC, as you can see, this diagram tells you a lot, like where a user is trying to access a certain instance that is lying in certain subnet and with appropriate firewalls and appropriate policies are being set, appropriate routes are being given. So VPC is the networking service offered by GCP. Now I'll briefly touch upon the identity and access management, because every major platform will have the framework that will guide like how to control the access to the services. So over here you see this is how this is called as identity and access management. We call it as IAM. This gives you the complete framework, how you can create accounts, how you can give access to different uh, over here you see the term called as principal, which is nothing but my own account. So let's come back to, so IAM lets you grant granular access to specific Google Cloud resources, help prevent access to other resources. So principle of least privilege. See, why this is important is because imagine a scenario where you have a resource that is getting accessed by somebody who is not authorized to access, and as a result you are incurring cost, because see, nothing is free in you know in cloud. I mean, every service, forget about the trial account that I'm talking about the actual project scenario where the company you know will set up certain resources and company would be getting a monthly bill, monthly invoice of the resources getting used. So having said that, this is to avoid the unauthorized usage resulting in unnecessary expenses. It becomes increasingly important to put the guardrails around who is accessing what service. Does that person is authorized to access that? If yes, under what capacity, under what circumstances, under what privileges? So all those things are configured in identity and access management. And it always operate with principle of least privilege, which is nothing but it says like, okay, give only the required privilege. A person should not have more permission than what is required. Okay, so I'll just briefly touch upon model of access management. Principle we just have seen, it could be a Google account. Like in case of a trial account that has been created by me, it would be my Gmail ID, for example. This would be, we will call it as principal. It is nothing but an entity to which the access is given or revoked. Now, the what permissions are being given is decided by the rule. These are very plain and simple terminologies which we have seen in other frameworks as well. There will be a policy that will decide, okay, what role needs to be given to what principal or what account. So that'll be decided. So these are some of the terminologies that are being used for access management. Resource we have already seen. Like for example, if a read access is given to my account on a certain storage bucket, like the one that I created, I have full admin access, right? So basically, this would be the resource on which I'll have certain, I have a certain role. as a principal, as a account user. So resources could be anything. It could be a project level, you know, project wide access, or it could be a very service level access, or so these are this is how it is categorized. So there would be a resource, there would be a principal, there would be a policy, there would be a set of formations decided by, we will call it as a role. So the policy will say, okay, give this role to this account on this particular resource. So it is as simple as that. So what we are saying is, okay, give a certain person a read access on a certain bucket. So so from this statement, we got the resource, which is nothing, which is bucket. We got the principal, which would be the Gmail account or any other account. Okay. And we got the role, which is nothing but a read access. So permission would be read access. So this is how it is. Permissions are nothing but so how it works is like, uh, cloud is nothing but a set of API calls that are happening behind the scenes. For example, if I am clicking on this bucket, what I am trying to do is there is an API call that is happening behind the scene. It says list the bucket. We call it as verb. At a very granular level. If I It says service dot resource dot verb. So service over here is Google Cloud Storage. Resource is my bucket, and verb is list. So this is how behind the scene the permissions work. So only if I will have this permission which says uh, Google Cloud Storage dot example bucket dot list. If I have this permission, then only I'll be able to list this bucket. So this is how the permissions work. And roles we have already seen. It's a collection of different verbs. Like, as you can see, compute, instance is delete. Compute is a service, instance is the resource, delete is the action, right? So these are different granular permissions. When they are clubbed together, it is called as a role. Role is nothing, like in this example, it says compute.instance admin. So a person who has this role will get these permissions, as simple as that. And this talks about like how we are binding a policy, allow policy, which is nothing but a collection of statements that define who has what type of access. So over here, these are the bindings. Basically, if you see the role compute.image user is bounded to a Google account, right? So this is how the policy works. Then I think we are almost on our last slide, but these are very important links I wanted to discuss. Google Quick Starts. So as a new user, this will be very helpful, to give you the jump start. It's a set of tutorials, a set of quick starts. For example, uh, if I want to do something related to compute, I'll click on compute, choose topic, and it'll give me a set of tutorials that I can work on. For example, deploying containerized workloads. So this is one example I'm doing. Then other areas is like if you want, but this will only, be useful when you actually go through the course, when you actually study all the services, then only you'll be in a position to do actual hands-on. But it is very much needed in order to get certified. So this is one useful link which I would highly recommend. And I wanted to come to this slide earlier, but I think it is making more sense now. So this is a four-step approach you can take. You know, the very obvious first step is to have thorough GCP training, learning all the services that are relevant for your engineering and architect certifications. Then the cloud skills boost is the next step, which is nothing but set of guided labs, and it is officially provided by Google Cloud. And once you cover these, let me also cover what exactly is Google Cloud Skills Boost. I think I have included the link to the Cloud Skills Boost in this slide. You can always explore. So it is nothing but you can sign up for the set of labs, like there will be certain paths. And again, they give you 1 month free trial subscription. Okay. And you can sign up with the Gmail account, normal Gmail account, and it will give you a set of guided labs. And when I say guided labs, there'll be a step-by-step. Let me see if I can sign in. I'll try to sign in with my. Okay, let's see. Not sure that's a complex one. Yes. Right. So I have this thing over here. These are set of guided labs. Uh, you can always, like, if I want to do cloud architect accelerated learning path. I mean, I can there. I think I can go to different. I'm just trying to explore it. So certain paths are there, okay, that you can explore, and then basically the Cloud Skills Boost platform gives you the ability to do hands-on, while there would be a set of instructions given to you, and it gives you the ability to provision your GCP account for the duration of the lab. So there will be certain set of labs you can perform, and they will give you uh, a separate GCP environment also that you can perform hands-on for that particular lab. This is a very useful platform. So that should be your next step. And then once you are done with the labs, relevant labs, like there will be certain relevant labs for cloud architect certification, certain for engineer certification. Once you are done on that, you need to cover up for the remaining 90-day, or if you have signed up, whatever tutorials you need to complete, you should do extensive hands-on after that. And yeah, that's the main, I mean, if you're thorough with the 3 steps, you'll be able to clear certification for GCP. So let me come back again to some of the. Now, this is another important link where you can go to the visualizations. These certain sketches uh, prepared by. Now, this is I think. Yeah, so if you see over here, some kind of sketches which will give you a very clear picture, like how, you know, like this is talking about uh, defense in depth at scale, infrastructure securities, what guardrails are there for infrastructure security in GCP. So this is again very useful. You can see the architectures clearly here. So this is one, and I think that's pretty much I wanted to cover. These are other links, like if you want to sign up for Google Cloud free tier, you can click and you can follow the process. Developer cheat sheet, and yeah, that's it. I think I'll just so developer cheat sheet is nothing but it lists down all the services that GCP. If you want to take a quick glance on what is available under what category, you can always see the cheat sheet. So as you can see, AI ML services, identity and security services, nicely segregated. These all are the services provided by the GCP. platform like compute. We have already seen storage, databases, data analytics, DevOps, CI/CD, networking. You know, I think that's all I wanted to cover as part of today discussion. I think that's all from my side. Unless somebody wants to ask any questions, I am open to answer them.